Hello everyone, this is class 17, task 1. We're basically examining RC circuit here. So we're making this circuit over here. We have a 1 kilo ohm resistor and 10 microfarad electrolytic capacitor. So over here, if you come over here, you see that I have 1 kilo ohm resistor and 10 microfarad electrolytic capacitor. So in this portion over here, we are basically supplying the positive voltage coming here, input, going through the resistor and coming back through the capacitor to the ground. So this is the output here. So you're measuring output across the capacitor, and input is basically these two bars right here, okay? So input is right here and output is right there. So what I'm doing here, we're using is a function generator. For the function generator, we're looking for 10 hertz square wave, 1 volt peak to peak, 50% duty cycle, and 0.5 offset, right? So let's do that. So come over here. First of all, I'm looking for a square wave, right? So let's select the square wave here, select the square wave. And frequency, we're looking for 10 hertz. I'm gonna go 10 and hertz over here, right? 10 hertz. And for the amplitude, we're looking for 1 volt peak to peak, 1 volt peak to peak here, that's set. And for the offset, we're looking for 0.5 volt DC right here. It's all set, right? So now, square wave, let's say frequency 10 hertz, amplitude 1 volt peak to peak, offset 0.5 or 500 millivolts, all set, right? So now I have to turn on the output here. So I'm going to turn on the output, then also turn on here the oscilloscope to see input and output. For the oscilloscope, I have channel 1 here, channel 1 right here, measuring the input, and channel 2 over here measuring the output. Again, input over here, input over here is these 2 points input, and these 2 are the output. So over here, if you come back to the circuit, this is your input measured by channel 1, this is the output measured by channel 2. So this is the common reference point for the circuit, all right? If you come over here, you can see that this is the channel 1 here, the square wave coming out from the signal generator. So that's the square wave, and this is the wave you're getting across the capacitor. What happening here, when you square wave goes instantly up and down, right? But capacitor cannot go instantaneously up and down, cannot change the voltage across the capacitor instantaneously. Thus, it's taking time, okay, taking time to decay the voltage and taking time to charge them. So discharging and charging taking time. That's the key point here. Capacitor cannot change the voltage instantaneously. It takes time to discharge. It takes time to charge. So if over here, if you come over here, we can draw this from here to here. So I'm going to draw. Let's say this is your input channel 1, right? Right. Then output over here is let's draw this one here. Output over here is gonna go like this, right? And coming like this, and you can see that. So that's your V out T, right? So now timing over here for the timing between this, you have to measure them for the time here. From here to here, right, and from here to here, and also how much time takes from here to go certain voltage over here. You can measure them. You can get these things measurement from your partner. I just show you what is happening over here. Then you will get the measurement data from your partner. All right, that's all for the task 1. We're going to go to the task 2.